Hi guys, welcome to today's lesson. So today guys, we're going to do some interesting stuff which I know that this is one thing that you guys understand and you are able to then get some answers on it. And I promise you, if you can master this, then clearly you then have some marks that you can then just pocket as soon as you get to paper one, because this is mainly about paper one, right? But the topic that we are doing is evaluating series, and this is under what we call number patterns. So let's just look at the roadmap of what exactly are we going to try and look at in this particular session. So we're going to look at what we call number patterns. As I just said, it's divided into two. It's a sequence and a series. I will explain what a sequence is about, and then under a series we have what we call an arithmetic series, a geometric series, some sigma notation there. With the geometric series, at times it is a converging one, at times it's a diverging one, and then also lastly it will be sum to infinite. That means me finding the sum of an infinite number of terms. But before, do you know what is the difference between a sequence and a series? Because really, if you do not understand this difference, I promise you, it's going to be a problem for you to understand what you need to do. But this is the leading question for this session. Also, is there a formula that you can use to then calculate the sum of a given sequence? If maybe I give you 1 plus 2 plus 3, what is the sum? You know, 6. But what then if I then give you a sequence and I say it's for 100 terms? Are you going to write all of them until you get to the 100th term and then add them? I don't think so. So that's why we then going to also focus on some formula to then do this. Now our keywords will be a sequence. Remember I said that, a series, what we call a common difference, and also a common ratio. Remember, difference is about subtraction, ratio is about multiplication and division, right? So difference is about plus and minus, by the way, because at times a difference between two negative numbers will normally be a positive number. And then now a sequence will be an ordered list of numbers or terms. Under number patterns, we're not really going to call them numbers. Instead, we are going to call them terms, right? Because I'm going to say term 1, term 2. You will see we use T as I've shown you here, right? It's T1, T2, T3. You continue T4 like that consecutively, by the way. You can't then say T3 and then the following one you say T7. Really, that wouldn't make sense. Hence we said it's an ordered list. Also, an arithmetic sequence, which is one type of a sequence, is when a sequence where the difference between consecutive terms remains constant. So the difference between T1 and T2 will be the same as the difference between the T2 and the T3, which will be the same as the difference between the T3 and the T4. That's what consecutive means. Not T2 and T4. No, it must be one after the other. Now, in an arithmetic sequence, we need to get some vocab out of the way. The A, we call it the first term. You will see I'm going to be using A a lot, which is T1. Also, we use the letter D, which means common difference. Remember, that's why I said the difference between consecutive terms is equal. And then also we have N, which represents the number of terms. Now, a series will be the sum of an ordered list of numbers or terms, right? Series is just you adding the sequence, right? So I had T1, T2, T3 continuous. As soon as I start adding them, we then call it a series. Now, an arithmetic series, because we're still talking about an arithmetic sequence, the arithmetic series will be when adding the terms of an arithmetic sequence, right? So we do have a formula to then calculate the sum of an arithmetic sequence, right? Which is the arithmetic series. When we know what the number of terms, we then use the formula Sn is equals to n over 2 into 2a plus n minus 1 multiplied by d. Obviously, You are not going to write it as Sn because you will then know what the n is, which can be 100, can be 500, can be 1,000, depending on how many terms they want you to find the sum of. But also, there will be a time where they just give you the series and they give you the last term. To then find the sum of that particular term, of that particular sequence, or series, you will then use Sn is equals to n over 2 into a plus last term, which is normally represented by L, right? Now, we have what we call sigma notation. Sigma notation, remember guys, we are mathematicians. As much as we are the smartest people, we are actually the laziest people. So we take these long things and we write them in a very short, concise way. And one way of writing a long sum in a concise way, we call it a sigma notation, right? And it is represented by a Greek letter which looks like a very funny E, right? Now, with the sigma notation, the top part normally is the number of terms, but I want you to then not always take it as what is there is the actual number of terms, right? It just tells you how many positions you have. And then the TK here will actually be the general term of that arithmetic series or arithmetic sequence at the time. And this represents the sum of the n terms. K is equals to 1 normally talks about the position of the first term. If I say K is equals to 2, I'm saying the position of the first term is actually at number 2, not at number 1, you see. So that's what it means. Now, Sn, as I said, will be the sum of the n terms. How do I find the n terms? It will be n is equals to the top number minus whatever that K is at the bottom plus 1. Let's make an example with this. The first position or the first term is at position number 1, agreed? And there's 12 at the top there. It means that position number 1, number 2, number 3, until you get to 12, there will be 12 terms. How do you get that? It's 12 minus 1 plus 1, which will just be 12. But as soon as I change it at the bottom, then it's a different story. But I will show you when you do an example exactly what I mean. Now, let's calculate the sum of the arithmetic series, right? It's 3 plus 7 plus 11, up until 30 terms. So firstly, I will say my A value will then be the 3 there. My D value, which is the difference, is the 7 minus 3, which is actually 4, which is the same as 11 minus 7, right? And then I start, my N value will then be the 30. I go to my formula. As N, you first start with the formula so that you know what you are going to substitute where. 2A plus N minus 1 multiplied by D. Our N, as I said, was 30, right? So let me just fix my equal sign there. My N is 30 over 2 into my A is 3 plus, and then my N there is 30 again, minus 1, and my difference is 4. Then you can just press your calculator, guys. You don't need to then try to do some mental math or anything of that sort, right? So this is going to be 30 divided by 2. You open the 2 brackets, but let me just open 1 because 2 times 3 is just 6. 6 plus, and then the 30 minus 1, which is 29. And then you multiply this by the number 4. And close the main bracket. This will give you an error there, so I must just put a multiply there, sorry there. It becomes 1,830. So the sum here will be 1830. Then you're done. But now, what did I say? Here it's Sn, right? As soon as you then know what n is, you must then say it's S30, meaning the sum of the first 30 terms. Now the second question is, now I know what the last term is. You can see they did not say up to how many terms, it's just the last term. So this will be a is equals to minus 1. The value of d will be minus 3 over 2 minus 1, which is the same as minus 3 over 2 plus 1. Therefore, this is minus 3 plus 2, which is actually minus 1 over 2. That will be my difference. And then my n value, I will first need to find what the n value is, right? Using the Tn formula. Tn is equals to a plus n minus 1d. The last term is minus 16 equal to, I need what the a value is, I know, minus 1 plus, I'm trying to solve for n. And this will be minus 1 over 2, right? So I'm just going to go to the calculator and do everything on the calculator. So firstly, it will be minus 16 plus the 1. I find what my answer is. I will divide this by negative, let me open brackets, by negative 0.5. And this will give me 30, and then I will add 1, which will give me, you can do it step by step. I'm just doing it so that I don't have to then do a lot of work, right? So it's n is equals to 31. Then automatically you can see that now I know the formula Sn is equals to n over 2 into a plus my last term, right? The n value is 31 over 2, so remember it's S31 into multiplied by the a value there will then be minus 1, and then plus my last term is minus 16. Then you press your calculator, guys. Remember, please don't worry yourself about doing mental maths here. So if I press my calculator, I will divide this by 2. I find my answer, you multiply it by, inside the bracket, it will be minus 1 minus 16. And my answer will be negative 263.5. Negative 263.5. And then you'll be done, right? Let's look at some sigma notation quickly. Now I said k is equals to 2. So it means the n value here is actually 23 minus 2 plus 1, which is not equal to 23. So 23 minus 2 will be 21, plus the 1 will be 22. What does that mean? It means position number 1, we don't look at it. We only start at position number 2. That's where my first term is going to be. And because this is an arithmetic series, you then know already that the value of d is actually 2 there. And then you can go straight to your formula, which is n over 2 into 2a plus n minus 1 multiplied by d. But for this to be easier for you, you just need to then list the first 3 terms, right? So term number 1 will be 2 times 2 minus 3, which is 4 minus 3. That's term number 1, right? Because the first position is at number 2. And then it will be 2 times 3, which is 6 minus 3. And then it will be term number 3, which is 2 times 4, which is 8 minus 3, so 8 minus 3, you see. And then you can then simplify it from there. This is 1, this is 3, and this will be 5. So you can see my difference is 2. You substitute it there, you get your answer. Let me show you. Remember I said the number of terms is 22, so it's 22 over 2. And I'm going to multiply this by 2 times 1 is the same as 2 plus 22 minus 1 is 21, that is, multiplied by the value of d we said was 2. Close your bracket, your answer is 484. So this is actually 484. And then you can do that step by step using your calculator. But that's really what sigma notation is about. So far, make sure you write down your data. What is A, what is D, what is the number of terms, and choose between the formula that uses the whole formula with the A and the D and the N, or the formula with just the a and the last term, provided you know what you are given, right? Guys, I hope that is very clear for you. But for now, let's just take a quick ad break. Drink some water, come back refreshed, and I'll be back with some more maths.